All right, in this video, we're going to be covering section 2.5, part 2, and this will be continuing our discussion on the fundamental theorem of algebra. And just to remind you, the fundamental theorem of algebra is simply the statement that says the degree of a polynomial indicates how many total zeros there are in the function, as long as you are including repeats and imaginary numbers. So on our first question here, our warm-up, we're just going to practice what we've been doing. So find all the zeros, write the polynomials, a product of linear factors, and then determine all the things we need to know, like x-intercepts and y-intercepts, and provide a sketch of the graph. Some of this we know. We know the end behavior already. So end behavior we know is going to be as x goes to negative infinity to the left, then the y values are going to go up. And as x goes to the right, y is also going to go up. We know the y-intercept is the point 0, negative 60. All right, so we have pretty much everything we need other than the zeros. And that, of course, is the part that's the most time-consuming, because now we need to guess and check to find those zeros since we don't know how to factor this by hand. So we are going to use the rational zero test. So factors of p over q, which is just going to be the factors of 60, since q is 1. So we've got, let's see here, 1, 2, 3, 4, 5, 6, all go into 60. 7 does not. 8 does not. 9 does not. But 10 does. And in fact, now we know we're to the point where we pair them up with the factors we found. So 6 times 10 is 60. 5 times 12 is 60. 4 times what? And am I right about 4, I guess, first of all? 4 times 15 is 60. 3 and 20. 2 and 30. And, of course, 1 and 60. So those are all my possibilities. And really know where to start other than just to get started. So let's take our coefficients, 1, negative 3, 6, 2, and negative 60. And if you're good at synthetic division, then stacked is going to be your most efficient, both with size and time method. All right, so let's just start grabbing numbers and give them a try. Let's start with 1. Okay, here we go. Negative 2, 4, 6 clearly doesn't work. Negative 1, bring down the 1. Negative 4, 10, negative 10 makes negative 8. Clearly doesn't work. So the 1s are out. Let's try 2. Let's see. Negative 1, 4, 10 does not work. Let's see. Negative 5, 10, 16. Negative 32 and 2 is negative 30, which makes positive 60, which makes 0. So I found 2 important things right now. First thing I've found is I've started to factor my polynomial. X, since negative 2 is a 0, x plus 2 is a factor. And we'll get to the zeros as a list in a moment. So now I need to continue factoring this. So I'm going to rerun synthetic division, but now I'm going to start here. And in fact, I could redo the rational zero test on this and see if I can eliminate some possibilities. So now my constant term is 30. My leading coefficient is still 1. So unfortunately, all that allows me to take out of the problem is 60, which doesn't really save us much time. -2 worked before. -2 could work again. So I'm going to now, again, I'm going to sort of ignore all of what came before. And now I'm going to start here. I'm going to try -2 again. Let's see, that's -7. That's +14. That's 30. That's -60. That does not work. All right, so we've done 2 and -2. So we'll scratch that off the list. Let's do 3. Suspect I might need more room here. All right. 3 makes -2, makes -6, makes 10, makes +30, makes 0. Oh, that was nice. So x equals 3 is a 0. In my factoring, I know that x minus 3 is a factor. And now I've gone from a quartic down to a quadratic. So I'm just going to go ahead and grab the other piece of this. X squared minus 2x plus 10. And can I factor that? Factors of 10 that add to be 2. That seems fairly impossible. So I can't factor any further. So I'm now going to resort to solving these factors by other means. Which I think I will use completing the square. I'm going to move the 10 over to the other side, making it -10. I'm going to take half of -2 is -1. I'm going to square it and add 1 and add 1. This factors now into x minus 1 squared minus 9. Square root. And answer 1 plus or minus 3i. These, of course, I already knew the answers to because that's how I got the factors in the first place. But just to kind of complete the work, those are my 4 zeros. Okay, let's see if we've answered what they've asked for so far. Find all the zeros, check. Write the polynomial as a product of linear factors. I have almost accomplished this. This one, of course, is not linear. So I need to write this as a product of linear factors, which just means I'm going to undo what I just did and write them in terms of linear factors. So my little clicker doesn't seem to be working, but looking at this x plus 2 area right here, if I add the 2 and make it equal 0, I've got my first factor. If I subtract the 3, I've got my second factor. Now, if I take these two guys and write them separately, 1 plus 3i and 1 minus 3i, x equals 1 minus 3i. And now, just like I did with these guys, I set them equal to 0. I subtract 1, I subtract 3i. There is my linear factor. So I subtract 1 and add 3i. And then there's my fourth linear factor. So I'm going to rewrite f of x as a product of linear factors. X plus 2, x minus 3, x minus 1 minus 3i, x minus 1 plus 3i. And that answers that part of the question. Okay. The x-intercepts, however, are not all of those. That's only going to be where the real numbers where x equals 0. And that's what all this work just found us. And so we know we have x-intercepts only at, and x-intercepts are points, so we'll write them as points, -2, 0, and 3, 0. All right, let's put all of this together in a quick little graph. We'll just make sure we label all the key pieces. I have my zeros. I have a y-intercept way down, not to scale, at 0, -60. My end behavior goes up on both ends. I have only these two zeros. So without doing a lot more investigation, really the only information I have is that the graph looks something like this. Now, if we actually graph this on our graphing calculator, we're probably going to see it looks a little bit different. But in terms of what we've done, this is as much analysis as we're capable of at this moment, unless we're going to just plug in a bunch of values. So what are the possibilities of what this could look like? Well, we know it could have up to 3 turns on it. And so what is the impact of these imaginary zeros? Honestly, without doing further investigation, I'm not sure, but let's take a look at some possibilities. So it could be coming down and maybe have like a full-on change in direction here and then settle into the zeros and the y-intercept. Or all that could happen underneath, like maybe it comes down and maybe it does a full-on like set of wiggles here, right? Or maybe all this happens over on this side or down here. We don't really know. And it may not even do any wiggles at all. I suspect it is doing something like this, though, that there is a little something happening with a change of direction, but it's just not reaching the extreme that it causes more zeros. But that's all speculation. And if I was really curious, like I said, table of values or graphing calculator to get the rest of that. But for our purposes today, that's good enough. Okay. So example 3, we're just going to kind of work backwards and pretend like we did all the work to get those zeros, and then let's recreate the polynomial that might have created them. So on part A, we've got a little bit of a contradiction here. I only have 2 zeros, but yet it's a degree of 3. So I know there needs to be a third 0, which hopefully means you guys agree with me. There's only one option here, and that is one of these has a multiplicity of 2. So I just need to recreate the factors. So if x equals 5 is a 0, x equals -2 is a 0, then we move the 5 over, of course, and get x minus 5 equals 0, and move the 2 over and get x plus 2 equals 0, making those my 2 factors. So this polynomial then has to be x minus 5 times x plus 2, and then one, but not both, of these has to have a power of 2 on it. So the multiplicity on this one could be 2, or it could be on the x minus 5. I'll put it on the 2 just to make the math slightly easier. Foil that out real quick. X squared plus 4x plus 4. And then distribute and give myself some room. I get x cubed plus 4x squared plus 4x minus 5x squared minus 20x minus 20. Add those together, I get f of x equals x cubed minus x squared minus 16x minus 20. And again, I want to stress this is one possible answer. As we said, another possible could have been to instead say f of x. Let's get rid of this arrow. It's confusing. One possible answer could have been to do x minus 5 squared x plus 2 instead. So that's another option. The other options could be we do either of those two, but then we multiply it by a constant. So f of x could be something like a times x plus 2 squared x minus 5. Or again, or f of x a times x plus 2 times x minus 5 squared. Any of these four answers, this answer, that answer, or these answers, which are just the previous two multiplied by an a value, would all have those zeros and have a degree of 3. All right, let's take a look at part B. This one looks kind of easier. We have a degree of 2 and we have two zeros. We have a constant term of 12. So that means we have to end in a plus 12. But let's see what happens with our first bit of information. So I know my zeros are positive 1 and negative 3. So I move those over and set them equal to 0, giving me my factors of the function, x minus 1, x plus 3. If I multiply this out, let's see, I'll do it in my head, x squared plus 3 minus 1, so plus 2x minus 3. However, that does not have a constant term of 12. Pen change, please. All right, my computer is not responding very well. All right, so if I need a 12 on this, I cannot just multiply by 12, because number one, multiplying everything by 12 would turn that minus 3 into a negative 36, so that's not right. So instead, I need to figure out what I can multiply this by to make it a positive 12. And so that means I need to multiply it by a negative 4. Because that will give me negative 4x squared minus 8x plus 12. And that, if I'm not mistaken, is the only answer that there is. There isn't options for anything else. There are some of you out there that might have thought for a moment that why don't we just add 15 to it or something. Well, if I add 15 to this, that would change the factoring. So that's not how we can get the 12. So that doesn't work. The only option is to figure out what we need to multiply it by. All right. Let's, if my computer behaves, let's take a look at the last couple of problems. All right. Part C, I want you to take a look at that. And hopefully you will come to the quick realization that there is a problem here. It's not a huge problem. It's something we can deal with, but we have a problem in that if we have a 0 of 1 minus 2i, the only place that could have come from would be the quadratic formula or completing the square. Either one has a plus or a minus in it. So there really is no way of just having these two zeros. X equals 6, x equals 1 minus 2i. If I follow this through, I get x minus 6 equals 0, and x minus 1 plus 2i equals 0, which means this function would be x minus 6 times x minus 1 plus 2i, which means I get x squared minus x plus 2xi, or let's do this. Let's call it 2ix. And then minus 6x plus 6, and then minus 12i. And when I add these together, x squared minus 7x plus 2ix minus 12i plus 6, that would be f of x, which isn't in the real number system. So this is not a polynomial, right? A polynomial has to have real number coefficients. Here we have imaginary coefficients. So this is not a polynomial. So it would be impossible to answer this question. Okay. So let's look at part D, which is the same question, but now I've taken off the requirement of how many zeros there are. So now we can kind of use the same analysis and say, well, x equals 6, x equals 1. Hey, wait a minute. There's no way to have just 1 minus 2i. I'd have to have 1 plus and minus 2i. And so what polynomial would have created this? Again, I'll work backwards. X minus 6 equals 0. And again, I've shown this before. I am not going to move all of this over. I'm just going to move the 1 over because I can get to the answer much quicker this way. Instead of writing like we did here with the whole linear factor, it's easier just to recreate the quadratic factor by undoing completing the square. Meaning, the last step of completing the square would have been to move the 1 over, so I put the 1 back. Then I would have taken a square root, so I'm going to undo that by squaring. That's plus minus. When I square it, of course, the positive and the negative both become 4. Positive 4, I squared, which is negative 4. This becomes x squared minus 2x plus 1 equals negative 4. X squared minus 2x, add the 4, plus 5 equals 0. So my two factors for f of x and now to put it in standard form, I would just multiply this out. All right, and that would be, again, not the only answer. We could get additional answers if we, change some multiplicity, multiplied by a constant, something like that. You'll notice this problem doesn't specify the number of zeros or the degree of the problem. And so we could have just repeated versions of these factors, which wouldn't violate what's been asked, but certainly is unnecessary. But just be aware that there are multiple possible answers if you wanted to be more creative. All right, so 2 more questions. I don't know if we'll answer them fully, but let's get them all set up. This one, again, doesn't specify how many zeros, so it's going to be a lot like the last one. We know that one of my zeros, 3 of my zeros, is got a multiple or is 0, and so one of my answers is x equals 0, and then once again x equals 3 minus I. We are aware that that means 3 plus or minus I. So what factors did these come from? Well, I get this when I set it equal to 0. In other words, I move the number over, but there's no number to move over. Obviously, the 0 or the factor is x. And so my function f of x has to have x 3 times. So that's just x cubed. And then my other factor is going to be a quadratic. Once again, let's recreate or undo the completing the square. Let's just move the 3 over. Let's square both sides. And I squared is negative 1. And move that 1 over. And there's my other factor. So f of x, actually we can just go ahead and finish this, is this factor times that factor. So I get x to the 5th minus 6x to the 4th plus 10x cubed. hit it with a constant to make it different, or leave it alone. All right, what do we got on this last question here? Find all the zeros given that 3 minus I is one of the zeros. All right, so all I know is 1. Actually, I know 2. So I know x equals 3 plus or minus I is one of my 2 or my zeros. So I only have 1 0 left. So the only way I can think to do this is let's figure out what this factor is that it came from, and then divide that factor into the polynomial, and that'll tell me what the third and final factor is, and therefore the third and final zero. So once again, I think this is one we just did, but to practice, here it's set again, move the 3 over, square both sides, and I get x squared minus 6x plus 10 equals 0. So I know that this polynomial here factors into x squared minus 6x plus 10 times some mystery factor, which I don't know. And so to find the mystery factor, I need to divide. Unfortunately, I cannot use synthetic division. 3, 2, 1, 0. All the terms are here. All right, we're going to get a 2 and an x. 2x cubed minus 12x squared plus 20x. I'm going to subtract all of that. So I'm distributing the negative. I'm doing that in my head. So 0, I'm going to get negative x squared, and I'm going to get plus 6x minus 10. So I'm going to get negative x. Nope, that's a lie. Negative 1. Come on, pen. You can do it. Oop. I probably need to restart my computer. It's bogging down here. 1 second. Okay. Minus 1. Negative x squared, positive 6x, and negative 10. And obviously, when I subtract this, I get 0, which is good because now I found my last factor and I found my last 0. So f of x equals x squared minus 6x plus 10 times 2x minus 1. Now, if I want to find all the zeros, I set each factor equal to 0. And this factor leads to the zeros I'm aware of. And this factor leads to add 1 divide by 2, 1/2. So my last 0 is 1/2. And just to call it all out and make sure it says find all the zeros, and then so my other 2 zeros are 3 plus or minus I. Okay, I hope this is all making sense, and with practice, you become stronger at this. If you have any questions, you know where to find me.